So we're going to start our next section, which is 13.1, which is about functions of several variables. So in the past, you've primarily seen we have only dealt with functions of a single variable. So, for example, you've looked at functions that look like f of x or f of t. So you have a single variable. In the first case, the variable is x. In the second case, the variable is t. But in the real world, many quantities are functions of two or more variables. And so let me give you some examples of quantities that are functions of two or more variables. So say the work done by a force. So it's work equals force times distance. So here work, W, depends on two variables, F and D. The second example, we're going to look at a volume equation. Volume of a right circular cylinder. So the volume is pi r squared h. So the volume depends on the radius of the circle and the height of your cylinder. And finally, our third example, you have volume of a rectangular solid, like a rectangular box, and the volume is length times width times height. So in this case, volume is a function of three variables, length, width, and height. So we're going to primarily focus on these two possibilities. We have a function of two variables. So in that case, our two variables are going to be x and y, f of xy, and we'll say that this equals z. And we have a function of three variables. So then our three variables are going to be x, y, and z, and our function will be equal to w in that case. So these are the two possibilities that we're going to focus the most on, is functions of two variables and functions of three variables.